Okay, so we're going to be doing some of the exercises here. I've been just browsing around the list now for a couple minutes, and I think that I'm going to try to do some. There's a lot of exercises. I'm not going to have time to do everything. I'm quite sure of it. So I'm just going to go and try to basically play with some of them and see what I can get out of this. I'll try to kind of chunk these things out video per, like one exercise per video. So it's easier to digest as well and easier for me to do because I really can't spend a lot of like time packed together in one long session. So we'll see, and we'll start first with this one. Should probably fire up VS Code, and so we've got here to distinguish between the direction of a CNOT. So we're given an operation that implements a 2-qubit unitary transformation and a CNOT gate with the first qubit as control and the second as target, or a CNOT gate with the second as control and the first as target. So I guess sort of one thing like these, right? And then the other one. So I'm going to see if I can put the other one. I don't know if I can use the same. Probably want to use the same. Can probably use the same. Yeah, something like this, right? And so what you want to do is you want to see whether we can distinguish which one we have, right? So and the separation measurement. So separation measurement 0 if it's 1, 2, and or 1 if it's 2 to 1. And you're allowed to apply the GUN operation, and it's exactly 1. So this is actually a learning from the. Oh, sorry, I still have the. Oh, this is the project that I want to have. Solution. Program 1. Program, exactly. So one of the learnings from the last session was that I can't just run like 1,000 times because the model is a bit different, right? So with QSharp, you basically have you're kind of a bit abstracted away from the concept of a circuit, right? So you just use qubits as resources and apply operations to them, and basically kind of if you are doing something like 1,000 times, it counts as if you would be running an operation 1,000 times, and that's what kind of the it's a bit dark. That's kind of what the what this forbids that. It says exactly once, and I think I had like my mindset was like exactly once in a circuit, and then I just run the circuit 1,000 times. It just doesn't count, but it actually it actually counts. Okay, so we've got these signature for the solving operations. So we're going to have so this is the solution. Okay, so and I'm gonna kind of copy the same code in here, or just what I will just do is why is it not moving? Just no. So let's see if I can. Basically, I will just copy this and replace this one here. And I locked my main, so I just to try to play with this. But the idea, I'm just going to keep it like running in one iteration. And what I'm guessing we need to do is we need to explore. So if I do these, they're the same result. Okay, so here, so if I play those gates with these already with these set up, right, we know it's easier to know because basically turns the second qubit on, and in this case the second qubit is off 100% of the times. So we can distinguish that. So if we apply the gate to the 1-0 state, then we should be able to know in which direction we're going. So if we are saying okay, we need 2 qubits, right? So how do we do this? So QSharp allocating qubits. With qubits. Qubits, borrowing. Where do I even go? What's this? Where am I going? How do you send a record? No, exploring. I'm lost. I'm lost. I want to see. I want to find. I guess I can just using qubit. Can I just declare an array of qubits or something like this? Right? I probably can. So I probably can do. Something like qubits equals, and then it's like an array of 2 qubits. So I don't know if this is going to work, but yeah. Can you go like this? Doesn't like the syntax? Qubit, or tuples. Tuples? Or it's just a notation thing, I guess. Can this just be then? Come on. Oh, like these qubits and qubits. Okay. So like these, and this is going to be just 2, and we're going to have. I'm not going to loop, so I'm going to get rid of it because I don't think I'm going to loop a lot in the next exercises. So I'm just going to clean that up. And I'm just going to generalize these because I don't want to keep changing it all the time. So we're counting something. And so what we're doing here is the, so what I would say is that we apply, so we say qubits 0 equals the unitary. No, what? Whoa. What am I doing? How did this even? I just completely forgot how. Oh, just apply things to qubits and then measure them. Okay. Yeah. So I would apply the unitary to Q1, Q0, and Q1, right? So I'm applying the unitary, and then what I want to do is I want to measure the second qubit. So this is qubits, and I want to measure the second qubit, right? Isn't this the right? How do you access qubits? What am I doing wrong? Qubit. Prepare uniform. What is the prepare uniform? Apply to each qubit. Why isn't this an expect argument tuple? How do you apply? Okay, so the unitary has. Oh, okay. I think it just eats qubits. So I think it just goes like these. It takes it. It applies. It applies the. Yeah. Okay. So that's either of these. And now what we should do is we should measure qubits 1, right? Is it correct? qubit 1 because that's what Quirk says. The qubit 1 is the one that's gonna, so if it's on, it means it's in the direction 1, 2, right? So we want the opposite, okay? So what we want to do is if result is 0. So if result is 0, I'll just call this like result, not count, because count is confusing. I'm gonna just return inside in here. I mean, that's really bad, but yeah, I guess I can return inside, right? So I can just return inside. Just say if the result is 0, return, what do we want? If the result is 0, we are in the case, so we wanted to return 1. Else, return 0. Okay, what is this? What is the, oh, we do have a main. What is this? No, sorry, this is something else. This is Silk. I'm gonna close this. So how do we have a how can I test these? How can I test these? I need the entry point. Okay, so I need these as an entry point. I guess I can just like test, right? And then I'm not expecting anything in here. And so I will just, what I will just do is I'll run solve. I have to put a semicolon here as well. No, what is the problem with operation? Return a value. So return solve, and I'm going to give it like a, so how do I call the C naught in Q sharp? Q sharp C naught. Come on, not Wikipedia. Okay, just C naught, right? So just C naught. So C naught. I guess I can just do this. The argument type, keep it. What is the argument? What's the problem with the argument type? Because the C naught has a, so I guess I got to make an operation called my C naught that basically takes nothing in here, or takes the same, it takes a unitary as a, just I'm trying to see what I would need in order to, so I need these. Stolen target, and I need these to basically my C naught. Oh, sorry, C naught control target, I really don't know if that's, sorry, no. Qubits 0 and qubits 1. And so this just returns, it just has qubits as an array of qubits, okay? So this takes these. And so this should satisfy, what's the problem here? Spec annotation, which is, I don't know what these all means. I'm gonna just use it. So, oh, it expects the result or something? Whatever. Item access. How do I test that? How can I just test that? So I cannot solve for the C naught because the C naught doesn't does not provide item access. Item access qubits. I guess what I can do is just pretend. So just look, I don't have time for this, so I will just do it the dirty way and do like a test operation that's the same, but it doesn't have anything in here, and it just has a hard-coded. Test solve, we'll call it test solve, and then it just has a hard-coded unitary, which is basically a C naught in qubits 0 and qubits 1. So, and so with these I should expect. How did I need to run these? Was it like done their run? So in here, I'm expecting what I'm expecting here. I did a 0 to 1, so I'm expecting to see a 1, to see on. So I'm expecting to see a 0 at the end. Yeah. But it doesn't, it's not. It should be fairly straightforward. Okay, what is it doing now? Oh, 1. It gives a 1. The variable count is assigned, but it's never value is never used. Do I have a count somewhere here? Yeah. Okay, cool. So that seems to work. Can we just comment everything out, or how do you do that in? What I should have is I should have a copy file save as program, or I'll just call it submit, and then in submit I just should have, so I should work in program to test stuff, and then I should just copy the operation in submit, and that's probably going to be more efficient. Exactly. This solution stuff, and now I should submit. So I should go in here and say, baby, please give me submit, and submit, and see what happens. See what happens. Should work though. What is the next? Come on. Come on. Come on. Wrong answer! Are you kidding me? Why? Should give you some clue. I mean, or was there anything in here that... So, did I do something? That result, qubits 1, measuring qubits 1. No, what am I doing? Am I missing anything in here? Solve, int. You're given an operation, it means 2 qubit unitary. I'm only using the unitary exactly once, right? Here, on qubits. On 2 qubits. And I am then measuring, and then if the result, measure Q1 if the result is 0. Oh, I'm stupid. The 1 qubit must be initialized. Oh, come on. So I need to do X on qubits 0 for this to work. Sorry. Sorry. That should work. That should work. Submit. Submit. Yeah, because basically, of course, it works for what I was showing, but I mean, it doesn't work for the case for other cases, right? Like, but that should really work. So I should apply an X to the first qubit before. I mean, I can test that here in the meantime. For this particular case that we do, for example, like if it's 0, 0, I'm going to measure 0 definitely. So runtime error? Okay, so let me try run these first. Okay, so we're going to try to run these first. Qubits 0. So what is it that it's not running well? So what is the runtime error here? We're doing test solve, and we're doing a next to qubits 0, and then we're doing C0 qubits 0 and qubits 1. Okay, what is it doing? Submit 715. Invalid callable declaration. A function already exists. What? What? What is it going on here? Oh. Okay. I mean, this is so I don't know if we should call test solve. Actually, I shouldn't have these here at all. It's whatever, dummy solve. Come on, shouldn't lose time on this. What's the problem though? It's like losing more time with getting these little things right than doing the actual exercise. Because I should, yeah, that's the. Yeah. Okay, so now actually something broke. Let's see. And how exception released qubits are not in zero state. So I gotta release. So I gotta turn the qubits off before releasing them, or Q sharp. Reset Q. It turns out I need to release the qubit calling reset. Reset does the following. Okay, so I need to reset qubits. Okay, so before releasing them, I should then do, so I'm doing test solve, and I should basically okay, but inside the using, or body using qubits, blah blah blah, using qubits return inside the using reset qubit one. Okay, so I should basically here I should just reset qubits 0, set qubits 1. I think that should do it. Correct? It's the reason maybe. So if that's the reason, then cool. Test solve. That would be the reason, then that would not be that bad. So I'm resetting the qubits. Maybe there's a way I can reset all of them just with one reset call, but who knows? Come on. Come on, come on, come on, come on, come on, come on. Okay, so warning, count in 0. So it means measure 1. Yeah, that makes sense. This count is also not needed here. Okay, but so this now could work. So I'm gonna submit. I'm gonna submit, and see what happens. Have I done this correctly? It's submit. Here it says solve, and I reset it to qubits after measurement. Okay. Let's see. Running on test 1. Accepted. Good. Then end of the video, and I'm gonna just right away shoot the next one. Perfect.